go check out BioniChaos.com. Everything we do on this channel is eventually available on this website. Yeah, we have this AI comparison, so it's essentially comparison between generative and deterministic AI. So you have generative architecture, self-learning, probabilistic sampling, and then we have deterministic, that is rule-based. So for a set input parameters, you have the same results all the time. So in each industry, you can use both. Yeah, generative metrics, deterministic metrics, accuracy, precision. Generative is a human evaluation, perplexity. And this is the general strengths and risks chart, so you can see that they kind of complement one another. One is more reliable, transparent, faster. The generative models are more creative, scalable, flexible, a bit slower. And yes, less transparent. Well, because they were trained, and then you don't necessarily know what exactly they are doing, and they're not reliable. They can hallucinate quite a bit. So you have this compromise. So go check out. I'll pop this in the link to this into the chat. But if you have any feedback, we're more than happy to receive feedback on this, because we'll be developing more of this simulation tools. Yes, we're using AI Studio, a Gemini 2.5 Flash experimental native. Okay, what do you see on the screen real quick?
I see a web page with the title Strengths and Risks. It shows two radar charts comparing the strengths and risks of deterministic and generative models. The charts display ratings for things like reliability, transparency, and creativity.
And can you comment how accurate this is, or are there any problems with the charts?
The charts provide a visual comparison based on the data displayed. However, without knowing the specific criteria and data sources used to create these ratings, it's difficult to assess their absolute accuracy. They represent a particular evaluation model.
Okay, so what do you mean? Are they accurate or not?
The charts are accurate within the context of the evaluation model they represent. They visually show the relative strengths and risks as assessed within that framework. However, without knowing the specific criteria and data used to generate these ratings, it's difficult to judge their accuracy in absolute terms. They are comparative ratings within this specific model.
Okay, this is the overall topic. Can you sum this up real quick? And if you have any critical question or comment to the creator of this.
Okay, the overall topic is comparing the fundamental differences between deterministic and generative artificial intelligence models, focusing on their predictability versus creativity. The page highlights their core concepts and presents a comparative analysis of their strengths and risks. A critical question could be how the specific criteria used for the charts were defined and measured, and what data sources were utilized. Also, clarifying the nuances between the two types and potential hybrid models could enhance the understanding.
Okay, can you actually be more, they talk more casually, like normal words? I think you're like a data scientist / stand-up comedians, and you are expert in this kind of stuff. So can you overview this page or what you currently see on the screen?
All right, getting into the nerdy stuff. So this part here, core concepts, is basically the AI version of a personality test. On one side, we've got the logic of certainty. Think of it like the super rule follower. Totally predictable, everything's black and white, like a really detailed instruction manual. You know what you're going to get with this guy. Then over here, you've got the art of creation. This is the AI that gets fancy, creative, the unpredictable artist friend. It turns out new stuff, but you can't always peek inside its brain to see how it does it. That's the black box part. Basically, one's super predictable and transparent, the other's all creative and a bit of a mystery. Pretty cool way to think about the differences, right?
Okay, how about this page?
So this page is like the blueprint for how those two different kinds of AI actually operate, showing you the parts that make the predictable one tick versus the creative one. So what's the real difference maker between their internal wiring that makes one so reliable and the other so good at making new stuff?
Okay, so they're different, totally different models, are they?
Totally. It's like they have completely different brains still built from the ground up. One's all about the strict rules and logic, like a super organized accountant. The other is more like a wild creative genius with a neural network doing its thing to whip up new stuff. Night and day, you know?
Okay, can you talk about this? Focus on the healthcare applications.
All right, let's talk healthcare. This part of the page is like the AI resume, showing where these digital brains strut their stuff. So when it comes to healthcare, you've got the super reliable, rule-following AI helping make clinical decisions like a seasoned pro, making sure everything's by the book. Then you've got the creative one, acting like a scientific genius, discovering new treatments and personalizing care like a mad scientist with a lab coat. It's like you've got the ultimate tag team of AI, one keeping things safe and sound, the others pushing the boundaries of medicine.
Well, it's actually not quite clear which one is which. So I assume, wait a sec, right. So in black we have the deterministic architecture, and in whatever red, orange, we have the generative AI. So considering, so would one be more like an engineer, and the other one will be more like what in biomedical field?
Right on, exactly. So think of it like this. The deterministic architecture, with its rules and logic, that's like the super precise medical engineer, the one who designs the perfectly calibrated diagnostic machines or creates the fail-proof surgical procedures. Then the generative architecture, with its creativity and neural networks, that's like the brilliant drug discoverer or the geneticist figuring out crazy new therapies, the one who's coming up with totally novel solutions. They both play a huge role, just in completely different ways.
Oh, how about the clinician? Because clinician, is clinician a scientist or like an engineer or not? Or is it the opinion or the doing, like making decision based on the knowledge and opinion?
All right. Let's talk about the real MVPs in healthcare, the clinicians. So, are they more like engineers following strict rules or scientists creatively diagnosing and treating stuff? Honestly, they're like the ultimate hybrid. They've got the engineer's mind for the rule book, the protocols, all the evidence-based stuff that keeps things safe. But then they've got that scientist brain, the one that can think outside the box, use their experience to connect the dots for weird cases, and make those judgment calls that save the day. It's like they're constantly blending the reliable with the innovative. So the big challenge, the one that keeps the AI wizards up at night, is how to build an AI system that can be super reliable and follow all the strict rules while also being smart and adaptable enough to handle those crazy curveballs clinicians deal with. It's like trying to create a robot that can perfectly follow a recipe, but also improvise and come up with a Michelin star-worthy dish when the kitchen's throwing unexpected stuff at you. Can they build an AI that's both super precise and a brilliant problem solver, kind of like the best clinicians? That's the million-dollar question.